Electroactive Polymer Haptic Devices, a virtual patent presentation by Michael Kuntz. Electroactive polymers are materials that change shape in response to electrical stimulation. Here you can see a strip of electroactive polymer sweeping away some sand and doing a fine job at it, I think. Over here you see a robotic hand that uses electroactive polymers as part of its fingers. But electroactive polymers are not only used in feeble electronics, they can be used in a number of other areas. The area I'm going to be looking at is haptic devices. So what is a haptic device? Well, I'll tell you, they're devices which communicate information to the user by means of a force applied to the user's body. In some areas, you've probably seen them already. Well, maybe not aviation, but you should know that if you're about to stall in an airplane, the stick starts to shake if it's a fly-by-wire airplane to tell the user that they are about to stall. In gaming, the haptic technology is used in force feedback systems to make the gaming experience a little bit more real. We all remember rumble packs, and we know them from gaming systems. Some cell phones incorporate haptic technology, so if you touch on the touch screen and make an input, it'll vibrate slightly to tell you that you did something. And that hand in the background there is a device which actually restricts the motion of the hand so that it can't pass through space occupied by virtual objects. So that's useful if you are a designer working with computers. But all those devices use electromagnetic actuators, and those are a very different thing than electroactive polymers. Electroactive polymers are really quite simple devices. They're just a strip of material and an electrical source. Electromagnetic actuators are a lot more complicated, tend to be bigger, noisier, and power hungry. So the difference here allows electroactive polymers to be used in ways electromagnetic actuators could never be used. So let's go look at some patents where electroactive polymers are used in haptic devices. So this first patent here is being assigned to Immersion Corporation, and that's expected since Immersion Corporation is really the leader in all sorts of haptic devices, not just those using electroactive polymers. It's just an abstract, but what you should be taking away from this is that this is a device that senses force being applied to it and actually pushes back to simulate the feeling of a key, a physical key press. If we look over here, we see another patent that has been issued to Immersion Corporation. And this is a sandwich structure. Some of those layers are electroactive materials. Some of them are display screens. And so you have here a flexible material that can be used to display information, but can also be deformed by pressing upon it, but can actually resist motion and force your finger back up by having the electroactive polymer stiffen and exert force on the finger of the user. If we look over here, we have another patent, and this one has been issued to the United States of America, or assigned to the United States of America. So this would be a patent that was funded with government money. And we look down here, this is a very different type of device, or at least by the looks of it. Basically, it looks like a very perforated piece of Swiss cheese, but actually each of those dots are little levers that are actuated by electroactive polymers. And what these are used for is that they push up against some sort of membrane and create a series of raised bumps. And where would this be useful? Of course, in braille displays for the blind. But it's also, I would say, in conjunction with these other technologies, very, very useful. When you have flexible screens and haptic feedback that approximates a key press, put those together, and you have a very, very interesting cocktail, which brings me to my next point, and this is getting into the applications of this technology. On our right is the cell phone when we started this adventure, and on our left is the same cell phone, but now with a QWERTY keypad up on the screen. Well, one on the right here with this wonderful piece of technology is really exciting and wonderful, except when you want to type on it, because you don't get any kind of tactile response. Well, of course, the one on the left is too there with the QWERTY keypad just displayed on the screen. But using these other technologies, you can actually make those virtual keys reacts quite similarly to a physical keyboard. It can be using that first patent, well, first and second patent, it can resist motion. And that third patent, and also some other patents, especially those by a company called Artificial Muscles, actually deform the surface of the screen upwards, so it can raise up those keys and make them quite similar to physical keys. And so with this technology, I think you're going to see eventually, some of the division between the physical keyboard people and BlackBerry types and the virtual keyboard people and the iPhone types kind of go away, since those kind of divisions will really no longer apply. So let's look at another application, and this one also is something that very much interests me. So without screens, no touch screens of any sort, you can still use this kind of tactile display to convey information to the user. On the top left of the screen there is just, well, it's just a watch. I just found that off the internet. It doesn't really exist yet, but imagine that you had a tactile display on the inside of that watch, on the other side from the face. You could have the time constantly displayed onto your wrist directly through tactile sensation. And you never would have to glance at your watch. Just by having a series of bumps representing the time, you would always know. That's kind of the idea behind the technology on the top right. That's the field space belt. It's basically a compass with a series of electromagnetic actuators all the way around its circumference. And keep in mind, those are electromagnetic actuators. That's why that's such a large and really awful-looking device. The idea behind this belt is that it'll always tell you north. That's the simple idea behind it. So when you're wearing this belt, whichever sector of your body is facing north, that actuator will be moving in order to, signal to you through your skin that is the direction of north. Use that long enough, and you'll have a perfect sense of direction. Uh, and at the bottom there, we have a flexible screen that uses the same kind of electroactive polymer actuators to actually make a display screen using each individual actuators, electroactive polymer actuators, similar to how pixels would act in a visible screen to convey information. We have all this skin, largest organ in the body. We might as well use it to pass information directly to our brain. You could have that on your finger, and if you would happen to know Braille, you could be reading emails while sitting in a meeting, and no one would notice. And the last application, kind of a joke, but it's teledildonics. Yes, that's exactly what the word looks like. If you Any new technology, first people to use it are the adult industries, and they've already started to use some kinds of electroactive polymers as part of teledildonics. And yes, that is what that means. All right, that is the presentation. Thank you very much.